Alright, before we start, I need to apologize because in typical Florkowski fashion, I made a mistake in the last two videos, and I realized that I did not have my headset plugged in while recording the previous two videos, which is why the audio sounds a little bit different, and you can hear every single time I touch the screen with my pen. So I'm sorry about that. I just I didn't realize it until I already made those last two videos. So it's fixed now, and we can get on with um, notes and in a more pleasantly sounding fashion. So today we're going to be talking about ratios, proportions, and solving them. And you guys have done this before, I know, in middle school or maybe algebra. Basically, we're going to be doing some cross multiplying a lot. So that is kind of the big idea here. So let's look at some definitions first. Now, a ratio can be written several ways. We can write it like this, A to B, or A over B. You will most likely see it written as a fraction because it is more useful as a fraction. An equation that says that two ratios are equivalent or equal is called a proportion. So, an example of that is kind of like when we reduce fractions. When we have 4 over 8, we know that's 1 over 2. It's the same thing. We reduce a fraction, we create another equal fraction. So let's start reducing some of these ratios. So we want to reduce them as simple as we can. So we want to say, okay, what's the biggest number you can divide 76 and 8 by? So we're basically reducing fractions. Right, we can divide both of these by 4. 76 divided by 4 is 19. And 8 divided by 4 is 2. So that is a simplified ratio. And you don't need units when you simplify ratios. Alright, now this one, you're sitting here, 4 feet and 24 inches. That's interesting. We need to convert these to the same units because 4 feet is actually bigger than 24 inches, but you wouldn't know that if you just looked at the numbers here. Each foot has 12 inches, so we can rewrite this as 4 feet over 2 feet. And then when we simplify this, we get 2 over 1 as our simplified ratio. Then letter C, 14 meters to 18 meters. Again, we want to simplify these two as much as we can. We can divide both these numbers by 2, and 2, 2, 9 is our ratio. And then finally, 33 yards and 9 feet. Well, again, they're not the same units. 9 yards, that's the same as 3 feet. So 3 yards to 3 feet. Because 3 feet is in 1 yard. Oh, sorry, 3 yards. Each yard has 3 feet, and 9 feet is what we're given. And then we can simplify this. You can divide both these numbers by 3 to get 11 to 1. Alright, let's look down at this example. And we've done problems that are similar to this before. just worded a little bit differently. So it says the measures of angles in triangle BCD are in the extended ratio of 2 to 3 to 4. Find the measures of the angles. So what I like to do is I like to draw a picture, and I just like to label the angles 2x, 3x, and 4x. And the reason I get 2x, 3x, 4x is from our ratio up here. And x is the number that we can reduce by. So then we can set up an equation saying 2x plus 3x plus 4x equals 180. And then we solve that. 2x plus 3x plus 4x, that will equal 9x. 9x equals 180. Divide both sides by 9. X will equal 20. So now we got to take 20 and plug it into each value because the problem asks us to find the measure of each angle. So 20 times 2 is 40 degrees. That's one angle. Another angle will be 3 times 20, which is 60 degrees. And last one will be 4 times 20, which is 80 degrees. So those are the three angle measures. Alright, if we look at the next one, it says the perimeter of a rectangular table is 21 feet and the ratio of its length to its width is 5 to 2. Find the length and width of the table. So let's draw a picture because I think that helps with what we're trying to do. And it says a perimeter is 21 feet, and the problem says the ratio of its length to width is 5 to 2, which means the width came first here, so that's 5. That goes with 5. The width came second, so that's 2. So the order will matter because the length of this table is larger than the width because 5 is bigger than 2. So over here in my picture, I'm going to say that the length is 5x and the width is 2x. Now since this is a rectangular table, it says right here, that means the width over here on the other side is also 2x. And we know the length down here is also 5x. And we know the perimeter is 21. So these four values need to add up to 21. So 2x plus 2x plus 5x plus 5x equals 21. So that gives us 14x equals 21. And then when we divide both sides by 14, x will equal 1.5. So that's what we're going to use now to plug in to find the length and width. Well, the length was 5x. So the length will equal 5 times 1.5, and the width will be 2 times 1.5. So we type those into the calculator. The width will give us 3 feet, and the length will give us 7.5 feet. So what we did, to kind of recap, we found, we drew a picture, and then we found the scale factor of 1.5, and then we plugged that back in to find out the lengths of the length and width of the table. Now, the cross product property is just a fancy way of saying to cross multiply. Where you multiply a times D and multiply C times B. So something you guys, I'm sure, are good with. So let's look at our examples down here. Solve the proportions. So we're going to cross multiply. We're going to do 3 times 16, which is 48, equals 4x. Divide both sides by 4. X is equal to 12. And that gets us our answer. Now, you could have also done, at the very beginning, said, wait, if I multiply this 4 times 4, that gives me 16. So if I multiply 3 by 4, that should get me 12, which is what we got when we cross-multiplied. But if you don't see that, that's okay, because you can always cross-multiply. You may see it in example B, where, all right, if I have 8, well, 8 divided by 4, that gives me 2. Well, then what number divided by 4 gives me 5? Or you could say 5 times 4 to get that answer. But cross-multiplying will still always work. So 8 times 5 is 40. And 2 times y is 2y. So when you divide both sides by 2, we get 20 equals y is our answer. Now the last part over here is a little bit tricky because we have some addition or some subtraction to deal with. This one, 3 times 2x is 6x, no problem. However, going across the other way, we got to multiply x and the negative 3 by 9. So if it helps you, you can always write it like this. You got to multiply both things by 9. So we get 6x equals 9x minus 27. When we subtract 9x from both sides, we get negative 3x equals negative 27. And then we divide both sides by negative 3, and we get x equals 9 is our answer. Alright, let's look at the next page, please. So there are some additional properties of proportions, and I'm going to be quite frank with all of you. Some of them are not very useful, but we're going to write them down and have them in our tool belt, but you'll see that a lot of times we'll just use one or two of them. So one of them that is particularly useful is if two ratios are equal, then their reciprocals are also equal. I call this flipping both fractions. So if we have, a ratio of 3 over 5 equals 9 over x, if we have that, you can flip both fractions and have 5 over 3 equals x over 9. And yeah, in this problem here, it may not seem as useful, but there are some situations, and I've run into it with SAT prep, where flipping both fractions has made the problems a bit easier. The next one, if you're going to change the means of the proportion, then you form another true proportion. So basically what that means is if we have A over B equals C over D, then A over C equals B over D. And that is one that I have not used as much. Basically what we're doing is we switch the location of, let me use a different color, of this and that, the B and C. Like I said, I've not used that very often, but it is true, and it does have some uses. And then the last one, if you add the value of each ratio's denominator to its numerator, then you get another true proportion. And what that looks like is this. So we have A over B equals C over D. And then that leads us to A plus B over B equals C plus D over D. So I took the denominator of each fraction and I added it to the numerator. I don't remember me using this one at all. I'm not saying it's not useful. It's just I don't remember ever using it, and I would not recommend it because you're adding more stuff to our problem. The point of solving problems is to get rid of issues, not adding more to it. So uh, we will probably very rarely use this one. So let's look at example number 4. So we want to write 4 true proportions. We're only going to write a couple of them because, again, usefulness. We don't want to do a lot of work that isn't going to help us solve the problem. It says that AC divided by DF, so AC divided by DF is equal to BC divided by EF. BC divided by EF. So the way I like to set up proportions, what makes it easier for me, is I take one value from one of the triangles, so 12, over the corresponding value in the other triangle, 18, equals, now because we started with this triangle, I put 12 here, which came from that triangle. In my second fraction, I want to use a number from that same triangle. So 9 over x. And you can solve it that way. Cross multiply and divide. What you could have done instead, and there's nothing wrong with this, is to say, you know what, I'm going to use both values in here in one fraction and say 12 over 9, 12 over 9 equals, well, if you do it that way, the side that's 12 units long corresponds with the side that's 18 units long. So 18 would have to go on the top, and then divided by x. So you could do it that way. And if you look, and we're still going to solve it in letter B. If you look at the two ones that we've written here, if you cross multiply, we get 12 times x. 12 times x. And 18 times 9. 9 times 18. So regardless of how you set it up, you get the same answer. So you can find the way that works for you. The first way I showed you is the way that works for me personally. So let's now solve this proportion. So 12 times x is 12x equals 18 times 9 is 162. And we'll divide both sides by 12, and x will equal 13.5. And that is our answer. You could have used this ugly thing up here, but then that would have just made more unnecessary work. Let's try to keep things simple when we can. Alright, in example 5, we got some tricky math to do. Looking at the picture, we see that this whole length from JH is x, but from JL is 2. What that means is the distance from J to L has got to be x minus 2 because we're missing these 2 units right here, the distance from L to H. So JH, the whole distance from J to H is x units, but the distance from J to L is x minus 2 because we got to account for these 2 units. So now let's look at our proportion that we're given here. It says JL over LH. Okay, so JL we said was x minus 2 over LH. Well, LH is 2, and that is equal to JK. JK is 15. So let's use this over kg. Kg is 5. 5. So then we'll cross multiply. We'll get 5 times x minus 2 equals, we'll cross multiply in the other direction, 30. When we distribute the 5, we get 5x minus 10 equals 30. When we add 10 to both sides, that will give us 5x equals 40. And then we divide both sides by 5, x is equal to 8. So now over in our picture over here, we know x is equal to 8. So JH is x, which we've calculated to be 8. JL, that is going to be x, which is 8, minus 2. So 6. And then finally, part B. Let's move over to part B. Says KL over GH equals JK over JG. Find GH. So we're just going to plug in what we know. We know KL. KL is 12 according to that picture. Over, we don't know what GH is, so I'm just going to leave that alone. Equals JK. How long was JK? Let's look over here. JK is 15. And JG. Well, JG is this whole distance, which is going to be 15 plus 5. So 20. Cross multiply. If you wanted to put x for GH, that would have been fine. You could have left that as an x, and it would be okay to use. So 12 times 20 is 240 equals 15 times GH, or x if you want to leave it as x. It's just this way we don't have to change it back to GH once we are done. Divide both sides by 15 and we get 16 equals GH. Okay. So I understand this was a very heavy lesson. There was a lot to it, a lot heavier than yesterday. So you may find yourself having to go back and rewatch some things, reach out for some help. I'll be happy to re-explain some things, but just make sure you're taking your time and that you understand what's happening. So I will see you guys later. Thanks for watching.